In this video, I will prove this summation formula. The sum of I start with 1 until n is equal to n times n plus 1 all over 2. In this case, I will use the sum of difference of square to prove this. So I will start with this. The sum of I equals to 1, right, until n of I plus 1 square minus I square. Okay, now first I will write out the expanded form of this sum series. It's still in terms of I. And then the second thing is I would completely write out this sum series. And the expanded form of this series here should equal to the sum series, right? Okay, so let's do this. This is equal to the sum of I equals to 1, right? And now I plus 1 all square is basically I plus 1 times I plus 1, right? Minus I square. Okay, that is equal to, we know that this is I square plus 2I plus 1, right? After you expand it. And then minus I square. Notice that I square and I square cancel out. All I have left is just this, right? 2I plus 1. Okay. The next thing is distribute the summation symbol to each term. Here, that is sum of I equals to 1 until n, 2I plus sum of I equals to 1 and 1. Now, over here, we do know that, right? This one, the sum of I equals to 1 until n. For 1, it's just equal to n. Here. So that will be plus n. Because you are adding 1 n times. So the sum of n of the 1, right? You have n numbers of 1. That's just n. Okay. Now second thing I will do is just use the sum of difference of square again. So here, I plus 1 square minus I square. So this is the same as this one. Here. So this time, I will write out the sum. How do we write this? Here, we start with I equals to 1, right? So we'll put 1 here and then put 1 here. So that is 1 plus 1 square minus 1 square. Plus, now I will be 2 this time, right? So we have 2 plus 1 square minus 2 square. Next, I is 3 plus 3 plus 1 square minus 3 square. Plus all the way now. At the end, plus, let's say here, n minus 2 plus 1 square minus n minus 2 square. And then plus, this time will be n minus 1 plus 1 square minus n minus 1 square. And then plus n plus 1 square minus n square. Okay, now what's that equal to? Now 1 plus 1 square is 2 square minus 1 square, right? Plus here 2 plus 1 is 3 square minus 2 square. Here, plus 3 plus 1 is 4 square minus 3 square. and then plus, right? Okay, here, plus. Now, n minus 2 plus 1 square is n minus 1 square minus n minus 2 square. Here, this one. Plus this one. N minus 1 plus 1 square is just n square minus here n minus 1 square. And then here, this one. N plus 1 square is n plus 1 square minus n square. So plus n plus 1 square minus n square. Okay, so now notice that in this series here, you can cancel 2 square with 2 square because it's 2 square here and minus 2 square here. Okay, so that cancel out. Plus 3 square minus 3 square, that cancel out. Well, based on this pattern, the 4 square here will cancel out with the 4 square here somewhere. Here. Okay, next, close to the end here, right? So everything would cancel out in the middle. Now over here, you can see that this plus n minus 1 square will cancel out with this minus n minus 1 square. And this n square would cancel out with this minus n square. Of course, over here, this minus n minus 2 square will cancel out with the plus n minus 2 square somewhere here. Okay, at the end, what is left? This one and this one. That's not cancel, right? So that would be n plus 1 all square here minus 1 square, which is the same as n plus 1 square minus 1. Okay, so notice that the sum of difference of square here is equal to the sum of 2i plus n. And this is the same sum of difference of square is also equal to n plus 1 all square minus 1. So I can equate this one and this one together. Okay, so I can say that here, this one. Sum of 2i plus n, sum of 2i plus n is equal to this, n plus 1 all square minus 1. Okay. In that case, I can take out the 2, right? It's a constant, right? Out of the summation mark. So 2 sum I equals to 1, n I plus n is equal to, what's this? We'll expand this. We have n squared plus 2n plus 1 minus 1. Okay, so the 1 and 1 cancel out. I have 2 sum of I equals to 1, n plus n. Okay, I, right, equals to n squared plus 2n. Now, subtract n from both sides. I have 2 sum of I is equal to n squared plus n. Now, divide both sides by 2. We need to isolate this sum of I. So I have n squared plus n all over 2. Now, here we can factor out the n as a common factor. So I have sum of I equals to 1 all the way to n, right? Sum of I is equal to n times n plus 1 all over 2, right? Okay, here. This is exactly what we are trying to prove here. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.